The objectives that were considered in the process included limit the damage due to structural failure, limit fire to fire compartment only, safety of egress paths, protection during construction, and protection of adjacent buildings. There were some concerns related to different areas, such as fire safety, structural safety. There were also some specific concerns related to firefighter safety, which is part of the fire safety objective. These concerns were taken seriously, and many requirements were added to address firefighter concerns. To address those concerns, it was decided that we want to target them during the development of the changes, considering the following. First, firefighter attack will be both internal and external, and specific requirements would be added to address firefighter safeties. The proposed change from BC and CWC were considered when it was decided to reintroduce two additional options for building size and construction relative to the occupancy. One is for Group C, major occupancy, which is residential, and the other one is for Group D, major occupancy. Two building blocks were added using the same recipe, but there are some key requirements for mid-rise. The requirements are to be considered as a whole package, including the provisions in the fire code. The requirements are both light frame wood construction and engineered wood. So it's not only for light frame wood. You can also see some engineered wood in those buildings. There are some additional requirements that deal with mixed occupancies as well. Special care was taken in reviewing the protection measures during construction, with the overall objective to reduce the likelihood of a potential impact to the neighborhood. Now let's explain the analogy between the building area and fire compartment area using Lego blocks. If you have a building that consists of 12 fire compartments represented by these 12 Lego blocks, the fire load is the same no matter how you group the blocks. In essence, the risk in a one-story building with 12 fire compartments is equivalent to the risk in a six-story building with the same amount of fire compartments. As you can see, the one-story building is converted to a six-story building with the same amount of number of fire compartments. First is building area. The first step is to define the physical limits of a six-story building of combustible construction. After we define that, we analyze the additional or existing protection measures that would provide an equivalent level of safety to both the occupants and the buildings with the current construction practice. For a six-story building, combustible building, the maximum building area would be 1,500 square meters with an aggregate area of 9,000 square meters. The image shows the scale of the proposed six-story combustible construction building in brown compared to a six-story non-combustible construction building in gray. Please note that there is no area limit for non-combustible buildings not more than 2-story in building height. Here's another way of showing the difference between the proposed six-story combustible building with what is being permitted currently for a 4-story combustible building and a 6-story non-combustible building. The proposed building area for a 6-story combustible building represents a 75% reduction in building area compared to the 6-story non-combustible building. A designer may also choose to use this new mid-rise combustible construction provisions to build a 4-story building. The building area up to 2,250 square meters, which is larger than the current permitted 1,800 square meters. However, the designer would be bounded by other requirements in the mid-rise combustible requirements. The mid-rise combustible requirements are to be applied as a whole package. You can't handpick some of the requirement and apply it to the 4-story building. The same principle was used to address Group D major occupancy. This image shows the new height and area for Group D major occupancy. For a 6-story combustible construction building, the maximum floor area would be 3,000 square meter with an aggregate area of 18,000 square meter. The image shows the scale of the proposed 6-story combustible building shown in brown and compared to a 6-story non-combustible building in gray. This represents a significant reduction in building area for buildings 2 stories or less, because there is no limit for such buildings in non-combustible construction. Again, here's another way of showing the difference between the new and existing requirements. This represents a 58% reduction in building area for a 6-story combustible building compared to a 6-story non-combustible building. Remember we talked about firefighter concerns? Building height is one of those concerns, which is that they may not be able to access the top floor level if the building is too high. So for building height, maximum height limitations for both the uppermost floor level and the roof level were chosen. 18 meters from the floor of the first story to the uppermost floor level include mezzanine. This requirement was added to prevent a 6-story building with a mezzanine effectively looking like a 7-story building from the outside, which is possible with some traditional buildings in the current building code. But using traditional requirement, a mezzanine could be provided on every story. But again, this requirement was added to prevent the building from looking like something else that is not intended to be. To address the firefighter concern, additional height limit for roof is added. A 25-meter limit to the highest point of the roof was set to determine the combustibility of the roof. This represents the level of comfort using effective hose stream of water to potentially extinguish a fire or limit a fire on the roof. Above 25 meters, the roof assembly should be either non-combustible or fire retardant treated wood with a flame spread rating less than 25. There are also some restrictions on roof coverings. The Class A classification is required above 25 meters. Another challenge identified by firefighters was how can we protect the exterior of the building from vertical fire spread while allowing the architects to explore some creative designs? We're trying to prevent fire within the building from spreading up from the exterior wall. So exterior fire spread was identified as a critical concern for these buildings. And so 2 options. A maximum of 10% of the surface of the building face is permitted to be combustible cladding, or combustible or non-combustible if the material is subject to testing in conformance with CAN ULC S134 standard and also satisfies the performance criteria in the code. The designers still need to comply with the construction requirement of the exposing building face, such as limiting distance requirement in the code. This diagram represents 3 buildings separated by firewall construction so that they are considered as 3 separate buildings. To allow access for firefighters to the building perimeters that would be acceptable for them in response to a fire emergency, mid-rise combustible buildings containing Group C and Group D major occupancies require that not less than 25% of the building perimeter be within 15 meters of a street or streets. What does that mean? Now take this picture as an example. Larger buildings subdivided by firewalls will need to meet the 25% perimeter rules. In this case, the building in the middle would not conform to the new 25% rule, while the other two would. So the middle building would not be permitted to be constructed using the new mid-rise combustible construction requirement. This new provision has a significant impact on infill project in urban areas, where street access on the side of a building is not always possible. So there's a recent proposed change to address this concern. We will discuss it in part 2 of the presentation. Another firefighter concern was access to the building. The elevation of access route relative to the uppermost floor area was limited to 20 meters to facilitate firefighter access to the upper floors and to the roof of the building. This represents a 2-meter elevation between the access route and the floor of the first story. Remember, we see the 18-meter limit. Now we have this 20-meter limit. This measure was found necessary to limit the potential construction of a 6-story combustible building on top of a hill, where the roof will be much higher than 25-meter height limit. The new requirement permits a combination of assembly, mercantile, low and medium hazard industry major occupancies, as well as storage garage. The main goal is to allow for occupancy combinations that are most likely expected in those type of buildings. The diagram on the left applies to buildings with a Group C major occupancy, and the one on the right side applies to building containing Group D major occupancy. In Group C building, with the exception of a storage garage for parking of vehicles, Group F occupancies are not permitted. But in Group D building on the right side, F2 and F3 occupancies are permitted. Both building types permit a storage garage to be located on the first 3 stories. Sprinklers. Historically, in combustible construction, fire spreads through concealed spaces and balconies. Sprinkler protection requirements are increased for mid-rise combustible construction buildings. Most concealed space within floor and roof assemblies will need to be sprinklered. In addition, exterior balconies will also need to be sprinklered to address the fire spread on the surface of the exterior wall assembly from one story to another story. As mentioned before, what if a designer chooses to restrain himself to a more stringent requirement for mid-rise combustible building and apply those to a 4-story combustible building because of the larger permitted building area? Then the NFPA 13R would still apply within the scope of the NFPA standard for residential occupancies. So there's no change for the building envelope requirements in Part 5 of the NBC for mid-rise combustible buildings, because the Part 5 contains performance-based criteria rather than prescriptive requirements. However, what is good for a 4-story building may not be good enough for a 6-story building. Several explanatory notes were amended to draw attention to specific issues for designers and engineers. In short, a higher building means higher exposure to elements and higher loads. Wood shrinkage, which is related to moisture content of the wood, is a well-known mechanism that is predictable. With respect to the building envelope, there are no new requirements, but there is a reference to CSA 086 in an explanatory note to address the shrinkage. CSA 086 specifies a method for calculating building movement due to the changes in moisture content. Okay. Wood frame buildings are known to perform well in earthquakes because the wood buildings are lighter, they can flex. For example, the nailed wood connections allow the buildings to flex, thereby absorbing energy. And the wood buildings, they also have redundancies. For example, they have numerous smaller connections rather than a few larger ones in other type of buildings. However, certain elements can create problems, especially when looking at a 5-story and 6-story combustible construction buildings. Therefore, from the structural and earthquake perspective, type 4 and type 5 irregularities and soft stories are identified as important issues to be considered by structural engineers. Two types of irregularities are not permitted when the seismic force levels are higher than a threshold value in the code. These irregularities are related to how to drive force loads through the structure in an earthquake. Type 4 irregularities are related to in-plane discontinuity in vertical lateral force resisting element. The diagram you see on the screen is a building section with the shear walls in the plane of the screen. In the left image, horizontal forces resulting from an earthquake would find a direct path into the ground. In the image on the right side, the shear wall panel is discontinued at the lower level, which may cause building collapse during the earthquake. For mid-rise buildings greater than 4-story, type 4 irregularities are not permitted when the seismic force are greater than a trigger value in the code. Here's type 5 irregularities. This is related to autoplane offset. An example of a type 5 irregularity is when the wood panel shear walls are shifted to a different plane at a story, as shown by the red shear wall panels on the screen. This is not allowed in mid-rise combustible buildings or 4-story in building height when the seismic force level are higher than a threshold value in the code. Now, what is a soft story? Envision a building where there are retail occupancies on the first story with a large windows. The story is potentially a soft story. Some of the most susceptible structures to earthquake damage are soft story buildings. A soft story refers to the existence of a building floor that presents a significant lower stiffness than the other floors. Larger openings in the walls, such as windows, doors, garage doors, can leave too little wall area to provide adequate resistance to the earthquake forces. In an earthquake, ground shaking causes structures to sway and sometimes the structure collapse. Building codes have recognized that buildings with soft stories have to be carefully designed and detailed to resist earthquake forces. The effects are not so pronounced for regular buildings which are 4 stories or less, but this is not the case for 5-story and 6-story combustible buildings. In building A, you can see the earthquake response in a normal building. Building B, the response of the building with soft story could lead to collapse. Story strength is less than that in the building above, leading to formation of a sway mechanism in the weak story. It was decided that the simplest method to address soft story issue is for 5-story and 6-story buildings would be to specify an increase in the minimum force level. Depending on which method to be used, different safety factors are introduced in the code. The previous slides have addressed almost all the firefighter concerns for buildings in the building code. However, we have to deal with the buildings when it is under construction. These types of buildings are in perfect condition for a fire, kind of like a wood crate where oxygen is available to the fire. The chosen the protection measures are expected to address first arson, second firefighter response time, and then protection of adjacent buildings. Arson is the leading cause of the fire on construction site. One of the most obvious measures that could easily be put in place is fence to limit the access to the site. Fence was already required in Part 8 of the NBC. Hot works and smoking are the second and third leading causes of fire on construction site. Now it is required to have identified smoking designated areas for mid-rise combustible buildings under construction. Currently, the National Fire Code addresses smoking, but with a different perspective. It prohibits areas where smoking is permitted, while the new requirement identifies and restricts smoking activities to dedicated areas only. This better reflects the current practice and is found to be a better proactive approach to control smoking on construction and demolition sites. Special attention was also given to disposal chutes and disposal bins where combustible materials could easily be ignited by arson. It is possible to spread the fire through the disposal chute into the building, potentially resulting in a major loss. The chute could act similar to a chimney. So there are two options to deal with this. First, either a 2-meter clearance to a disposal bin, or you use a non-combustible disposal chute. Most 911 calls come from workers on site. To help construction personnel better identify which stair or which section of the building they're in, temporary signage is now required at every floor in a stairway that are commonly used to access each floor. Also, signage is required outside of the building. The information required on the sign should help the firefighter more efficiently gain access to the site, to the building, and to the floor where the fire is identified. As soon as construction materials arrive on site, a water supply must be provided. Water supply is not defined. The new provision requires adequate water supply for firefighting. It may be a municipal water supply, or it may be a water tank, may even be a water truck, whatever solution suits the need of the local fire department. A stairway need to extend upward as each floor is installed in the new construction. The same step configuration, handrail, guard height design for permanent stairs are applicable to the construction stairs. This doesn't mean that such stairs will meet all the requirements for stairs in terms of elevation, evacuation, but it provides a reasonable level of safety for firefighters gaining access to the floor area for firefighting purpose. The stairway doesn't need to be temporary scaffolding as shown in the picture here. It could be the finished stair in the building as long as the step dimensions, handrail, guard meet the requirement stated in the code. The construction stairways are provided so that firefighters can easily have access to the fire floor. Now, we have covered several topics, but the biggest three takeaway from this part is there are some new design options in the code that permit the mid-rise buildings of combustible construction. When the building is finished, mid-rise combustible buildings have the same risks as other buildings using conventional construction techniques. Third, there is a specific recipe for those buildings that need to be followed. This concludes part 1 of the presentation on mid-rise combustible construction. These changes were published in the 2015 edition of the National Building Code and National Fire Code. here's the part 2. Following the publication of the 2015 codes, a few issues and concerns were raised by the industry and authority having jurisdiction in Canada. The task group and standing committees addressed these issues in the past 5 years. Now let's have a look at those recent proposed changes for the mid-rise combustible buildings, which will be published in the 2020 code. Street access was meant to address fire spread and firefighter access to the upper floors. We're already learning about the practical application of this requirement from actual projects in Canada. This is a geometry issue. There's simply not enough real estate on the property to fit another road, and it is too difficult to meet the 25% requirement for building parameters. To address this, a new change was proposed as a second compliance option, which harmonized the National Building Code with the Ontario Building Code. Street access is proposed to be reduced from 25% to 10%, given that the exterior cladding is completely non-combustible. Since many requirements were introduced in the code that apply strictly to new mid-rise buildings up to 6 stories, it was not clear if the requirements apply to a portion of the building that comply with the mid-rise combustible construction. There's a new proposed change. It was intended to clarify that the requirements for fire blocks in mid-rise combustible construction applies not only to the building that is entirely constructed under the new provisions, but it also applies to any portion of a building that uses the new requirements. Since the publication of the 2015 code, there have been some confusions from the code users, designers, or regulators across Canada as to what occupancies are permitted in mid-rise combustible construction buildings. We have already seen these two figures on the screen before. So these two figures answer the questions from the code users, but it seems there are still some questions about it. So in the 2015 to 2020 code cycle, several proposed changes were developed to Part 3 of the Nbcc to explicitly tell the code user what occupancies can be introduced and where they should be located. CSA 086 standard introduced cross-laminated timber platform type shear walls as a seismic force resisting system in their 2016 edition. But this system is not currently listed as an acceptable SFRIs in table 4189 in the building code. So it cannot be used by the industry as an acceptable solution. So the industry raised this concern to us, and the standing committees developed a proposed change to add this system into the table as a new SFRIs system, so it can be used in the future for mid-rise combustible construction buildings. The 2015 National Fire Code requires a 3-meter clearance between the container and the exit of the building. Now the new change requires 3 meters between the container and the exit or any portion of the building. For a product that cannot meet the requirement due to some site limitations, the proposed change also provides another mechanism to address the fire hazard by implementing other equivalent protection measures as determined by the designer and the authority having jurisdiction through the fire safety plan. That means you can either follow the 3-meter clearance, or if you can't, you just work with the AHJ to develop a fire safety plan. Now, this is the last slide of part 2 of the recent proposed changes regarding mid-rise buildings. They will be published in the 2020 code. Well, we call it 2020 code, but actually they will be published in next year. Okay, part 3 will show you how those mid-rise combustible buildings are being built in Canada. As mentioned in the beginning, Coast Canada doesn't collect such information from the industry. So we reach out to Woodworks BC. They agreed that we can use their case studies. So you can view the following slides on their website, along with a lot more case studies and presentations available on the website. Okay, let's get started here. This presentation is about light wood frame mid-rise constructions in BC. An important question to ask is when it comes to wood frame mid-rise buildings, can we just keep adding 2 more stories on top of a 4-story building? And we talked about this already. The answer is no. We can't just simply add 2 more stories on top. There are some challenges for mid-rise combustible constructions, most of which we have discussed in the previous slides. So I'll go through this part fairly quickly. There are some pictures taken during the construction to show you how the challenges are addressed in the recent projects and what those buildings look like. This is the building height requirement for mid-rise combustible construction. As mentioned before, we cannot use the top floor mezzanine to achieve an additional height. It should be noted that the code reference on the slides here in the case study is for BC Building Code. It's not for National Building Code, but the provisions in the BC Building Code are essentially the same as National Building Code provisions. The code reference is just slightly different than Nbcc. The maximum floor area is calculated using the same gross floor area divided by the number of stories. We have covered this in one of the previous slides. Only non-combustible materials or fire retardant treated wood siding will be allowed to reduce the fire on building surface and spread to adjacent buildings. Here's a typical picture of the mid-rise combustible construction building. As discussed before, Type 4 and Type 5 irregularities are not allowed for buildings of combustible construction over 4-story. This provision provides structural engineers with directions for shear wall designs in the code. For light frame multi-story buildings, consideration should be given to the uplift and overturning resistant system. Connections such as shear wall and hold down relies on being installed tight and remaining in this tight condition in order to resist the overturning and uplift forces. However, as shrinkage occurs in wood frame buildings, the tight connection at the end could be changed. In such case, slack in this system can be used. This is an example of a component that holds down the lumber, which is in tension, marked in green. This is another example of the component used that holds down the lumber that is in compression. Threaded rod system with shrinkage compensation device can be installed to address the material shrinkage issue, particularly for buildings of 5 or 6-story stories in building height. The floor shrinkage should also be considered when designing other systems, such as continuous post doesn't shrink, but the floor does. The balcony slope should slope to the outside of the building, but the slope could reverse when the shrinkage of the floor occurs, causing water to enter inside the buildings. Then how to deal with that? One solution could be support the inner edge of the balcony deck by the same type of columns as used for the outer edge. then the slope should be maintained instead of reversing. But there are some other approaches for designers to choose to address this issue. Building brick cladding can expand due to moisture change. If there's a differential movement between the brick veneer and wood framing, there could be issues such as cracks in the brick veneer and water leak through the cracks. Mechanical, electrical, and plumbing lines could also be damaged by building shrinkage. Special accommodation should be provided to protect those mechanical and electrical and plumbing systems. Wood framing can also be impacted by shrinkage. This is not, well, the picture here is not common for a 2-story building or 3-story building. Building codes require all building systems to perform to the same level of the safety, regardless of what material is used. So wood stud, steel stud, concrete, or masonry walls can be designed to provide 1-hour fire resistance rating. The two figures at the bottom show that there's difference for sprinkler requirements between a 4-story building and a 6-story wood building. Now the attic and balconies of the green building on the right are required to be sprinklered. Here's a sprinkler height on the balcony. Here's some pictures of the standpipe installed in the mid-rise wood frame constructions. Some more pictures of the hose. And we have talked about some of these issues on the previous slides, such as smoking policy, hot works. They are addressed in the fire code already. With more and more mid-rise buildings being built in the next few years, the industry may realize more issues from the practice. New code change request is always welcome so that the standing committees can discuss and address the practical issues encountered in the industry. When a new floor is built, the standpipe should be tested and in operational condition. This is a new change that is expected to be included in the 2020 National Fire Code, and this applies to encapsulated mass timber construction. BC was one of the first provinces that adopt mid-rise combustible constructions. There were some fire safety bulletins issued in BC a few years ago to address the challenges for mid-rise buildings in the past years. When the Atlantic provinces permit 5- and 6-story mid-rise buildings, you guys can learn from the previous experience from BC to see how the local authority having jurisdictions regulate such projects. Coast Canada does not collect those information, but we can certainly, if you have any questions, we can connect you with the building officials and fire officials in BC and Alberta as well, who have more experience dealing with the practical issues with the mid-rise buildings and even higher buildings. With the new provisions in the codes, designers, building owners, contractors have a new option to achieve a higher building using wood. And it has some unique advantages compared to the concrete and steel constructions. The industry reacted positively to the new mid-rise construction in general and requested to permit even higher wood constructions. This was addressed by adding encapsulated mass timber construction in the 2020 code. There's a lot more materials that may be interested to you. Woodworks BC has a lot of presentations and seminars on their website in case you are interested. This case study is from their website as well. In the end, I would like to thank Suk Johal and Woodworks BC again for sharing the slides with us. If you have any questions, feel free to reach out to Suk and browse their website for more information. Now that we have seen the changes for mid-rise combustible construction in 2015 and 2020 codes, I have a few more slides to show you before we open the floor for questions. Following the publication of the mid-rise provisions in 2015, the industry requested to permit even higher wood constructions. Therefore, encapsulated mass timber construction will be introduced in the 2020 code. This will allow the industry to build higher wood buildings up to 12 stories. We also call this EMTC for short. In response to industry trends in construction technology, a new type of construction classification is called encapsulated mass timber construction, or you call it EMTC, has been proposed to be introduced into the 2020 National Building Code and National Fire Code. For the purpose of the National Model Codes, EMTC is defined as a new type of construction in which a degree of fire safety is attained by the use of encapsulated mass timber elements with minimum cross-sectional dimensions with a covering encapsulation rating. Basically, mass timber plus encapsulation equals to EMTC. The essential characters for this type of construction is that there are requirements for minimum dimensions for the major structural wood elements, as well as there's some requirement for encapsulation rating to be applied to these mass timber elements. Encapsulation rating refers to the time that a material or an assembly of materials will delay the ignition and combustion of the mass timber elements when they are exposed to fire. Buildings up to 12 stories in building height constructed using EMTC will now be included within the acceptable solutions in the National Building Code 2020. The prescriptive requirements include provisions for mid-rise. The prescriptive requirements include provisions for mixed-use occupancies and cladding, just to name a few. Requirements are also introduced into the National Fire Code to address some specific issues and risks related to the EMTC buildings, particularly during construction. Some of you may be aware that EMTC buildings have been or are being built in Canada already. BC and Alberta have already adopted 12-story EMTC provisions even before we published those provisions in the 2020 code. Since the focus of today's presentation is on 6-story mid-rise combustible construction, I'm not getting into too many details of EMTC. But if many of you are interested, we can certainly arrange another seminar specifically for EMTC in the 2020 code. Here are some websites that may be of interest to you. The national model codes are free to download since April 2019. You can place an order online and then download the PDF version for free. All the public meetings are posted on the second link, and they include the commission meeting, standing committee meeting, task group meeting. Please check it regularly if you are interested, and you can feel free to attend any meetings you want to. Some general information is posted on the website of Codes Canada to help you understand the code development system. On the construction innovation blog, we regularly post some articles and updates of the proposed changes, research project at the NRC, and some other information in the construction industry. Okay, now it's time to raise your questions if you have.
Great, Nick. Thanks. That was a great presentation. So as Nick just mentioned there, we'll open the floor to any questions. just type them in the Q&A section down below, and I'll read them off. There isn't any right now, Nick, but we'll just give it a couple minutes there.
Okay.
Okay, yeah, it doesn't look like there's any questions, Nick. So it means that you did a good job in answering all the questions throughout the
Okay.
presentation. So I thank you again, and thanks everyone for attending. So that will conclude the webinar. Thanks.
Okay, thank you.